Welcome to another exciting video for mathematics brought to you by Up Vision Concept Academy. Now, in this video, we're going to be looking at some questions, some JAMB Past Questions in mathematics. And we're going to be diving into the years, solving the questions, and getting solutions. So we're starting off with the JAMB Past Questions for 2010. And two questions here says, we skipped number one because number one was asking the paper type. Though this particular question sample I'm using is type B. And the question one says, what is your paper type? And the answer is type B. So that's very simple. All right, so number two says, find R if you have 6R7 to base 8 is equals to 511 to base 9. Now, for this kind of question, you have two different numbers. You know, we did number numeration and number systems. So you see that you have two bases. This is in base 8, this is in base 10. Sorry, base 8 and base 9. So they are equating two of them and saying you should find a missing digit here. Now, what we'll do is to convert the both of them to base 10 on both sides. And we said in our previous video that to convert from other base to base 10, you do multiplication. You expand each of the digits here by the current base, understand, and apply and allot powers to the tenths of the digits. See how we're going to do it. For this one, I will just say 6 times 8 plus R times 8 plus 7 times 8. Now, this is, I'm trying to expand this to base 10. So 8 is having the power of 0, here power of 1, and here power of 2. It's equals to the same thing applies here. 5, we are going to this base times 9. That's we are using this base times 9 plus 1 times 9 plus 1 times 9. The power here is 0, the power here is 1, and the power here is 2. Okay, so we'll do this starting from here. 8 raised to power 0 is 1 times 7 plus 8 raised to power 1 is 8 times R plus 8 raised to power 2 is 64 times 6. For this side, I'll start from here. 9 raised to power 0 is 1 times 1 plus 9 raised to power 1 is 9 times 1 plus 9 raised to power 2 is 81 times 5. So I'm going to do all the algebra. 6 times 64 is 384. 384 plus this R times 8 is 8R plus 7 is equals to 5 times 81 is 405 plus 9 times 1 is 9 plus 1. At this point, I have 384 plus 7 is 391 plus 8R is equals to, this is 415. Do the maths. 8R is equals to 415. So goes over minus 391. 8R is equals to 24. R is equals to 24 over 8, which is equals to 3. So 3 is the answer for this. So this particular missing digit here is 3. So by the time you do the math, if you convert this one to base 8, for base 8 to base 10, having 3 here, you will still get this particular 415. So that's the answer for that one. So we'll quickly go into the next question in the series of questions that we have. Number two says simplify. Sorry, number 3 of 2010 says simplify 3 over 4 of 7 over 9 divided by 9 whole number 1 over 2. This is simple fractional mathematics, but at the same time, we must be careful with the operations that are used here. So this operation of is actually multiplication. So it is 3 over 4 times 7 over 9 divided by, I will change this one, this is an improper fraction, to a proper fraction. So it is the same thing as saying 9 times 2. 9 times 2 is 18. 18 plus 1 is 19 over 2. Okay? So I will still rewrite this expression 3 over 4 times 7 over 9. Then this one changed to times, and this last term in that I have 2 over 19. Okay, so at this point, I can do my cancellation. Okay, so I have 2 goes here, 1, 2 goes here, 2. I have 3 goes here, 1, 3 goes here, 3. So I have 1 times 7 times 1 is 7 over 2 times 3 is 6. 6 times 19 is 114. So this is the answer for this particular question. Okay. So question 4. Question 4. Question 4 says a student, let me write it. Question 4. Say a student measures a piece of rope and found that it was 1.26 meter long. If the actual length of the rope was 1.25 meters, then what was the percentage error in the measurement? What was the percentage error in the measurement? Okay, so this is the question. A student measures a piece of rope and found out it was 1.2 meter long. If the actual length of the rope is 1.25, what is the percentage error? Percentage error is equals to the measured value minus the actual value over actual value times 100 degrees. So this is percentage error. Okay, so there's a difference. You measured something, but actually is the real measurement, but you measured and overshot. Understand? So the difference between the overshot measurement and the actual measurement is the error. Now the percentage error is that error divided by actual value times 100. So we can get every parameter from here. Measured value is 1.26. That's what he measured by mistake. Meanwhile, the actual of the measurement of the rope is 1.25. Then over actual, 1.25 times 100 over 1. So do the difference. The difference at the top is 0.01, 0.01, 0.01 over 1.25 times 100 over 1. So the final answer here is 0.80 degree percentage, percent. So 0.80%. That's the final answer. Okay. All right. At this point, I would like you to subscribe to the channel. If you are new to the channel, please subscribe. You can make a comment. Maybe ask 1 or 2 questions in the comment section. We'll look at it and we'll get back to you. And also, if you like the page, if you are impressed with that. we are having. So we'll quickly go to the next question. Number 5. It says, at what rate will be interest on 400 naira increase to 24 naira in 3 years, reckoning in simple interests. Okay. At what rate? So simple interest SI. Simple interest SI is given as principal times rate times time. Principal times rate times time. The rate is in percentage, or you can say all over 100, but the rate is in percentage actually. So from what's in this question here, we're told that at what rate. So at what will be R? At what rate? Understand? Will be the interest on 400. 400 is the principal. Understand? Increase to this. So on this 400, there was an interest of this. So this is the interest, simple interest. This is the interest, and the time is 3 years. So let's plug in the parameters. Simple interest, that's the SI is 24, is equals to principal is 400, R is R, we're still looking for it, and T time is 3 years over 100. So at this point, I can have 24 times, okay, it's divided by, let me just divide this by 400 times 3 is equals to R over 100. Okay, so what is here now? 3 here 1, 3 here 8. 8 here 1, 8 here 50. So 1 over 50 is equals to R over 100. So by the time I plug it this way, when this one comes up, R is equals to 100 over 50. R is equals to 2. That's 2%. 2% is the rate. There are many ways of solving this thing. You can just, I'm just playing with this. I just put this one down, but this one can go up first, and this one can go down, and so on. But the thing is that when you get to this point, make R subjects, and then you get your answer. Okay, so that is for number 5. Now, number 6 is interesting. Number 6 is very, very interesting. Please subscribe to the channel so that you can get notification for new videos, and turn on the notification bell. Also, comments and like our channel. So number 6 says, if P to Q is equals to 2 over 3 to 5 over 6, and Q to R is equals to 3 over 4 to 1 over 2. Okay, find P to Q to R. So this one is ratio. And the concept of ratio, if you have these 2 dots here, it means that this divides this. This is a quotient. This ratio is a quotient. If I come and say, for instance, 2 to ratio 3, it's the same thing as saying 2 over 3. This is a quotient. So please take note of this. Please. Take note of this. Let me take off this slide. Okay. All right, so this is what we have. So they said if this P to Q is 2 over 3 to 5 over 6, and Q to R is 3 over 4 to 1 over 2. What is P to Q to R? Now, the first thing we'll do is to just make this in simpler. This is in fractional form. Let us make it in linear form. So for this first one, let me just rule my line like this so that I can, because I see this thing is going to be a little bit long. So P to Q is equals to 2 to 3. I should work on this one, make it neater. What is common here? What is the LCM in these two fractions? Is 6. So I will just multiply both of them by 6. So P to Q is equals to 6. That's the common one. 2 over 3 to 6 again. 5 over 6. So that I'm just doing it so that this one can be a non-fractional form. So P to Q is equals to, when this one comes to 3 here 1, 3 here 2, that's 4 to 5. That's for the first one. Second one, Q to R. Q to R is giving us 3 over 4 to 1 over 2. So I look at it, what is common here? What is the LCM here? Is 4. So I multiply both sides of the quotients by 4. So Q to R is equals to 4 outside, then 3 over 4 to 4 again outside, 1 over 2. So I just did the same thing. Understand? So 4 cancels 4, that's 1. 2 here 1, 2 here 2. So Q to R is equals to 3 to 2. So I have two expressions. But we want to make it like this. Like this. Let's say, for instance, here I have here as 5. I would have just said this one is 4 to 5 to 2. See, P mirrors to 4 and Q mirrors to 5 for this particular expression. Q mirrors to 3 and R mirrors to 2. So already I have what P is and I have what R is defined, but Q is taking instance of 5 here and taking instance of 3 here. I cannot marry them like that. So I have to look for something to do to this and this. Let me call this one ratio 1 and this one ratio 2. So let your eyes be on these two ratios. I have to look for something to do to these two ratios so that this one and this one will be the same thing. So I'll say multiply. You know, in mathematics expression, you must do the same thing. Multiply to both sides. Multiply ratio 1 by, let me pick a number. I can swap it. So multiply it by 3 and ratio 2 by 5. So I'll follow what I've written here. So ratio 1, that's here. So P to Q is the same thing as, I multiply this one by 3. So this is 4 times 3 is 12 to 5 times 3 is 15. So this is still ratio 1 transformed. Then I multiply, I do Q to R. So this one is by 5. 3 times 5 is 15. So 2 times 5 is 10. Ratio 2. Now let's look at ratio 1 and ratio 2. See that my Q is having 15 here, and my Q is having, so is equal. I can marry them. So therefore, P to Q to R is the same thing as saying I pick P is 10 to Q is 15. See it, to 15, and R is 10. So this is the answer. Okay. So we go to the next one, to the next question. So we are in question 7. Question 7. It says evaluate. Question 7 says evaluate 81 over 16, open bracket, minus 1 over 4 upstairs, times 2 raised to the power minus 1. If at this point you have not subscribed, please subscribe so that you can get more exciting videos, more educative, more problem solved mathematics close to your reach. So for this particular expression, I can take this one and express it as indices, this one inside here. So 81 is the same thing as saying 3 raised to the power 4, and 16 is the same thing as saying 2 raised to the power 4. So what I have here is the same thing as I just expressed it in that form. So I can put my raised to the power 1 over 4 times 2 raised to the power minus 1. So I've broken it down. So still with law of indices, because this is the same power, I can still group this one like this and use the same power to raise them. And this is 60 dot minus 1 over 4. This dot is times 2 raised to the power 1 minus 1. So at this point, 4 will cancel 4. That's the power. So I have this one as 3 over 2 all raised to the power minus 1 times 1 over 2. Let me go to this side and finish it up. So at this point, this one I can invert it because I have minus 1 here as power. So I can say 1 all over 3 over 2, you understand? And this minus 1 becomes plus 1, so it's just 1 times 1 over 2. So you see this thing, the way this thing is, it's the same thing as saying, 1 times 1. This is numerator and this is denominator. All over 3 over 2 times 2. So this side is numerator, this side is denominator. So this 2 can cancel. So what I have is 1 over 3. That's the answer. That's the simplified form of these indices. Okay? So we progress. Okay. Okay, so at this point, we'll go to the next question. The next question is number 8. Number 8. So it says, number 8 says, given that log 2 is equals to 0.3010, log 7 is equals to 0.8451, evaluate log 112. So whenever you see where JAMB is giving you is defining a lower log value, anytime JAMB just tell you, say, given that log 2 is equals to this and log 7 is equals to this, and then that give you a bigger number of log, I say evaluate. Find a way of breaking this one down so that you will have them in this form. They have actually defined this log as this, so that is this what you're going to use to now solve your broken down version of this one. So you break down this one first. So how do you quickly break it down to look like this? My advice is to, first of all, get the factors of 112. So just rule your line first. Rule your line. 112, you put 2 outside here. 2 into this one is 5. Into 12 is 6, 56. 2 into 56 is 2, 8. 2 into this one is 1, 4. 2 into 14 is 7. 7 into 7 is 1. So these are the factors of this one. So that means I can do a combination. Already I've gotten 7. 7 is here. So, and this one 2 is here. So 2 is expressed as 2 raised to the power 4. So I can say, therefore, log 112 is the same thing as saying log open bracket 16 times 7. 16 times 7 can still give me 112. So log 112 is equals to log 2 raised to the power 4 times 7. So I can say log 112 is equals to log 2 raised to the power 4 plus, because of the times here, become plus log 7. So at this point, I will come here and say log 112 is equals to, this 4 will go down to be 4 log 2 plus log 7. Log 112 is equals to, now I know that log 2 is defined here as 0.3010. So it's same as saying 4 times, put log 2. When you see log 2, put this one. 0.3010 plus log 7 is what? 0.8451. So from here on is simple mathematics. 4 times 0.3010 is giving us 1.2040 plus 0.8451. Therefore, this log 112 is the same thing as saying 2.0491. 2.0491. That's the answer. That's the answer. Okay, so that's number 8. Okay, so number 9. Rationalize. Number 9. Number 9. Rationalize 2 root 3 plus root 5 all over root 5 minus root 3. So we should rationalize this expression. So the first thing we'll do is to identify the denominator. This is the numerator and this is the denominator. Rationalization means that we should look for the conjugate of the denominator and multiply both numerator and denominator by the conjugate. So what is the conjugate of the numerator? Conjugate. The conjugates. Check out my video on sorts. The conjugate of root 5 minus root 3 is root 5 plus root 3. So this one that is the conjugate, multiply it by numerator and denominator. So I come here, that is what they call rationalization. And the purpose, the aim, the goal is to give the denominator to be a real number without the without the roots, to make it in a non-complex form. All right, so let's rationalize. 2 root 3 plus root 5 all over root 5 minus root 3. So upstairs, I multiply by the conjugate, which is plus. Downstairs, I multiply by the conjugate again, which is plus. What I'm calling plus is the center one, center operation. Operation at the center. So how do we do that? By the time, look at it, do it one by one. This first term here times the first term inside the bracket. So this times this is 2 root 15, because 3 times 5 is 15. I've done with this first one. So this one again, this times this plus, that is 2 dots, because 3 root 3 is 3. So I've multiplied this one. This 2 will stay like this. Root 3 times root 3 is 3. So I'm done with this 2 for this first one. So I go with this one now. Plus, root 5 times root 5 is 5. Plus, root 5 times root 3 is root 15. So I do the denominator. So for this one, the bottom one, once you see conjugates multiplying the denominator, just work on this and this, then this and this, put minus at the center. Don't do what I'm doing on the numerator. So just say root 5 times root 5 is 5, minus root 3 times root 3 is 3. That's what you do for the denominator. Now we are going to pay diligence to the numerator and work very carefully. So this is 2 root 15. Then this one is 6. 6 plus 5 is 11, plus root 15 all over 5 minus 3 is 2. So I continue here. So now 2 root 15 and plus root 15. You have this kind of expression you are going to take it as if it's an algebra, where root 15 is like an A or a B or a C, unknown. So there's a coefficient for root 15, which is 2, and a coefficient for root 15 here, which is 1. So 2 plus 1 is 3 root 15 plus this 11 all over 2. This is the answer. This is the answer for this addition. So answer is 3 root 15 plus 11 all over 2. So we move on to the next one. So at this point, please, if you're not yet subscribed to the channel, please subscribe, hit the notification bell so that you will get notification if a new video comes out. You don't want to be missing the videos posted by Operation Question Academy. Very important that you get it first. All right, so number 10 says, express the product of 0.21 and 0.34 in standard form. Okay, so express 0.21 and 0.34 in standard form. The product means times now. That's 0.21 times 0.34. Okay, so in standard form. So I can just move this point like this. So if I move it 1, 2, that's 21 times 10 to the power minus 2. Then times 1, 2, 34 times 10 to the power minus 2. Now when this one multiplied with this one, if you use a calculator, you get 914, and this one is 10 to the power minus 4. We add it because it's the same base. You add the power. The power is minus 2 and minus 2. That's minus 4. But this point, to make it a real standard form, I move my dot again twice, 2 places, and reduce this one and increase this one by 2. This one will increase, this one will reduce. Or this one will go from right to left, and this one will increase. The power will increase. So I have 9.14 times 10 to the power minus 2. That's the answer in standard form. Okay? All right. So the next one is number 11 of 2010 past questions for mathematics, number 11. If you have type B, question type B, that's the one I'm in a sample. It says, which of the following Venn diagram, number 11, say, which of the following Venn diagram, okay, represents P prime intersects Q prime intersects R prime. Now in this question, they gave options for the different Venn diagrams, you understand? But I'm going to go ahead, go space, and just analyze this and draw the Venn diagram. Now when they say P intersects, okay, now the Venn diagram contains elements sets P, Q, and R. Now first of all, there's always a universal set that looks like this. You draw it in a rectangular form. So I have set P, I have set Q, I have set R. Okay, set R. Now this operation here shows that they are intersections. So, but this, we are told to find P prime. P prime is whatever is not in P, intersects with whatever is not in Q. What in R? I'll take it again. P prime means that whatever is not in P intersects with whatever is not in Q and intersects with whatever is not in R. It simply means that the area you are looking for is areas that are outside this. You will shade all the areas and leave P, Q, and R. See the answer. That's one of the options. It has this. Just shade it like this. This is the answer. This is P intersect Q, intersect R. Nothing. They are not intersecting at all. Don't draw any line inside. Don't shade inside, shade outside. So this is the answer. So this answer represents P prime outside, intersect Q prime outside, intersect R prime outside, everything outside all these ones intersect together. That is the answer. Okay. Now, question 12 follows another question on sets. Please check out my video on sets. My video on set, check it out. That's why I say you should subscribe. Subscribe so I can getting videos of this topic. It says, in a survey of 50 newspaper readers, yes, I was wondering, newspaper readers, okay, those are read newspaper. They said 40 read Champion is newspaper, and 30 reads Guardian. How many read both papers? How many read both papers? So we'll look at it. First of all, I like to draw the Venn diagram. The Venn diagram, always I like to draw Venn diagram. I'm a Venn diagram person. So this is the universal set. So that is 50 of them. They have just 2 sets of people there. Those that read, I will denote those that read Champion. 40 read Champion. So Champion is C. C is equals to 40. 40 read Champion, and G is Guardian. How many we get 30? G means Guardian. So what is X? X is the intersection. How many people read both papers? So the formula for this is actually N is equals to number of those that read Champion plus number of those that read Guardian minus the intersection X. So this is the formula. So those that read everything, universal set is 50. So some people read Guardian, some people read Champion 40, some people read Guardian 30. So it's possible that some will read both Guardian and Champion. That's what we're looking for. This one, X. So 50 is equals to, this is 40 plus 30, 70 minus X. So we can look for X. This one goes over to join this one. That's 50 minus 70 is equals to minus X. This difference is minus 20 and minus X. So therefore, X is equals to, by the time you remove the, cancel both sides, the minus on both sides. So I get X is equals to 20. So 20 people read both Guardian and Champion. If I want to get that, those that read only, I want to go ahead though. If I want to get that, those that read only only Champion, I'll just subtract X from this. That is 20 from. So only 20 reads Champion, and from here only 10. That is 30 minus everything here. Only 10 reads Guardian. So this one, 20 reads. So if you add everything together inside, 20 plus 10, you still give us this one. You understand? The answer is actually 20, but if you want to get, if the answer, the question also went further to say, find those that read only Guardian. You understand? Just subtract everything. That's what, who reads Guardian, those that read Guardian, from those that read both Guardian and what's it called, Champion. You get this 10. You understand? And for the other one, you can subtract this intersection from 40 here to get 20. So this is how we go about with sets. So let's go to the next one for this particular video. All right, so that's number 13. I take this one off. At this point, please again subscribe to our channel to get more videos. All right, so number 13 says, make Q the subject make you the subject of formula. Make you the subject of formula. If P is equals to M over 5, open bracket Q plus, sorry, X plus Q, close bracket plus 1. So this is the question. Make Q subject. So in this expression, where is Q? So where Q is hidden inside here. Inside here. So I'm going to make it stand alone. So bring this one. So there's a video I made on transposition of equation, making a variable the subjects. So currently now P is the subject, but we want to bring out this Q and put P inside, put everything inside and bring Q out to be here. So the first thing we do is to let Q be free from this cage, this bracket that is here. So what we'll do is just expand this side of the equation. So I'll come to this side, I'll say P is equals to, so I open the bracket, M over 5 times X is MX over 5 plus M over 5 times this one is MQ over 5 plus 1. At this point, I'm going to also multiply each term by 5 so that this denominator will disappear. So just as I'm calling it now, you will just do it like that. Multiply each term by 5. The good thing about the video is that you can always rewind and play if you miss any step. So 5p is equals to 5 times mx over 5 plus 5 times mq over 5 plus 5 times 1. You see what I'm doing? 5 is appearing in each of the 10. This is 1, 2, 3, 4, 4 10. 1, 2, 3, 4, 4 10. Each of these 10 is carrying 5, 5, 5, 5, 5 as the multiplicand. Okay, so I say 5p is equals to 5 cancels 5. What I have left is mx plus 5 cancels 5, mq plus 5 times 1 is 5. Now you see what is the purpose of doing this multiplication by each term by 5 is to remove this denominator down. So I've made this expression simpler. So, but my goal is to make a Q subject of formula. So what I will do, I will just bring every other term that is not attached to Q to this side by changing the operation before it. So if it's a plus that is before this, when it crosses, it becomes minus, or if it's a minus, it becomes plus. But in this case, I'm having plus plus. So 5p, then when this one crosses, m and x crosses, it becomes minus mx. Then when 5 crosses, it becomes minus 5. Is equals to, this one now remains mq. At this point, to make q subject, I'll divide both sides by n. So 5p minus mx minus 5 all over n is equals to q. So q is subject now. It can be in this side, it can be in this side. If I flip it that way, it is q is equals to 5p minus mx minus 5 all over n. So that is q being subject of the formula. All right. So we'll go to the next question. All right. So it says, that's number 14. Still on 2010 JAMB Maths. So we are moving forward. Question 14. Question 14 says, if 9x squared plus 6xy plus 4y squared is a factor of 27x cubed minus 8y cubed. Find the other factor. Okay. So you look at this. You know, JAMB has a way of repeating, some topics. So if you look at this one actually has this form. They call it difference of cube. You know, difference of square, difference of 2 squared. It's also difference of cube. If difference of cube, let me put it, difference of cube. If I have a cube minus b cube, it's the same thing as saying a minus b into a square plus ab plus b square. This is the form of the rest of the cube. So this is just like a formula. Whenever you see this one like this is the factor, this is how you break down. So our goal is to break down this one to be like this. Already they said one of the factor is this one, or one of the factor of this is this one. But let us solve it so that when we see this one, the other one is the other factor we are looking for. You understand? So the first thing we'll do, is to rewrite this one in the powers of 3 because I'm looking at difference of cube. So 27, let me write it here first. I'm working on this. 27 is something as 3 cube dot x cube minus 2 cube dot y cube. See, this and this are the same thing. I just expressed 27 in index form, 3 cube. I expressed 8 in index form, 2 cube. You see, with this thing we are doing, I'm taking time to explain. But if the exam, you have to be very fast because you don't have time. And I'm explaining because you are taking time because I'm teaching, I'm explaining. It's like for me, I don't take time to solve things like this. So, but it's all right. You just have to know the basics. When you know how to move, you know the road, then you cannot know how to move fast. All right. So at this point, I can now group these two in one power. So 3x all cubed minus 2y all cubed. So you see that this guy is looking like this guy, where A is this one, A enters here, and B enters here. Just visualize it. A enters here, B enters here, and this one. So I want to write this one in this form using what I have inside here. So I go. So this A is 3x minus B is 2y. Already, this is my answer because the other factor is this one. But let me just finish it. If I'm writing JAMB at this point, I'll just pick this one. This is in the option. I'll pick it. I don't have to go for that. But I'm trying to tell you that this is actually difference of cube. So I open bracket. Now a square is actually this. What's inside here? Square. This is a inside the bracket. So it is 3x all square plus AB is 3x times 2y. So I open 3x times 2y, and b square is 2y. 2y then all square, close bracket. So let me work on this one. I will prove to you that this one is actually already this one. And the other one we are looking for is this one, which is the answer. And if I was writing the JAMB, I will stop. I will quickly go and pick this one and continue. I don't need to. But I'm breaking it down for you to show you that this is actually from difference of cube. So I still write this one because it's still part of the factors. Then this one, remember this is 3x squared. So this square is affecting these two, 3 and x. So 3 squared is 9 and x squared is x squared. Plus this is 3 times 2 is 6. X times y is xy. Plus 2 squared is 4 and y squared is y squared. So see now, this one is the first factor which they gave you in the question, and this is what they're looking for. So the answer, the other factor is this one, 3x minus 2y. Okay, so that's number 14. Then number 15, they say factorize completely. Let me take this one off. Remember, I am using the type B question for 2010. If you have it, follow. Understand that every type is reshuffled or different. So when in order of what I'm following is type B maths. So you say factorize, number 15. Factorize completely. So I have x squared plus 3x squared minus 10x all over 2x squared minus 8. Now for this one, factorization just means that you just try and simplify. I know that there's a factor here. x is common. So I just take x outside, then I write the remaining things up as x plus 3x minus 10. So that's what's remaining. All over. This one is 2x squared. Okay, so let me factorize this one. 2 is gone here. So if I put 2 outside, what's left is now x squared minus 4. At this point, I can add these two. So x outside, x plus 3x is 4x minus 10 all over 2 into x squared minus 4. So this one too can be broken down. There's a common factor here. X into, there's 2 is common. Let me just say dot 2 comes out. And what is left here is 2x minus 5 all over 2 dot, this one too is difference of 2 squared. X squared minus, x minus 2 and x plus 2. So this can cancel this. That's the only thing that can cancel. If this one was the same thing as this, I can cancel, but it's not the same thing. So what I have here is x into 2x minus 5 all over x minus 2 and x plus 2. That's the answer to this particular question. Okay. So we'll go on to the next one. Okay, number 16. Number 16. Number 16. Number 16, it says solve for x and y if x minus 2 is equals to 2 and x squared minus y squared is equals to 8. So this one looks like a simultaneous equation. Just that this one here has, they are not linear. This is linear. This is linear. And this one is not linear. Why is this one linear? Because the highest power of the variable is equals to 1. This one is quadratic because the highest power of the variable is equals to 2. Highest power, yes, of the variable. Highest power of the variable here is equals to 1. So, but there's something we can do. We can do something. Just let me just rule line. This will be a long haul. X minus y is equals to 2, equation 1. X squared minus y squared is equals to 8, equation 2. Meanwhile, this equation 2 can be simplified with difference of 2 squared. So equation 2 becomes x minus y, x plus y is equals to 8. Let me call this equation 3 because it transformed. But from 1, when I mean equation 1. From 1, we have defined x minus y is equals to 2. So when I put this one in 3, where I see x minus y, I put 2. So I have 2 here into x plus y is equals to 8. I can divide both sides by 2. So x plus y is equals to 4. This is equation 4. So I have, from this equation 2, I have broken down equation 4 like this. I'm going to solve 1 and 4 simultaneously. So solving 1 and 4. So 1 is equation 1 and 4 is equation 2. Equation 4. Solving 1 and 4 simultaneously. I can now say from 1, I want to use substitution. From 1, x is equals to, when y goes the other way, becomes 2 plus y. So from 1, this is this. Let me call this equation 5. Please don't be confused. Equation 5. So I will say put equation 5 in equation 4. Substitute or put 5 in 4. Where is 4? This is 4. Whenever we see x, we put 2 plus y. So 2 plus y, I'm writing 4 again, 2 plus y is equals to 4. At this point, I say 2 plus y is 2y is equals to 4. Therefore, collect like terms, 2y stays in this place, 2 goes to the other side. It becomes 4 minus 2, which is equals to 2. So y is equals to 2 over 2, which is equals to 1. So y is 1. If y is 1, I can now say substitute again. Substitute y is equals to 1 in equation 5. Any equation can work, oh, we are putting anything, but this one is easier because I already have x as subject. In equation 5. So equation 5 here says x is equals to 2 plus y. Y is what? 1. So x is equals to 3. So therefore, x is equals to 3 and y is equals to 1. Or you can see it like this as coordinates, where x is the first one and y is the second one. So that's the answer for number 16. So we'll solve one more question and stop here because of the length of the video, because it's going to be broken to another video. So I'm going to quickly resolve this. I'm trying to look at the time. That's why you'll see my face there. Look at the time so I can know where to draw the curtain. Okay. So for the last one, 17, it says if question 17, that's what we are. Say if y varies directly as the square root of x and y is equals to 3, where or when x is equals to 16, calculate y when x equals to 64. Okay, that's it. So this is a direct variation. So subscribe so I can see the video for variation. By dropping videos and you subscribe, you'll be getting it. Okay, so look at the expression here. Y varies directly, direct variation, varies directly as the square root of x. So this is the particular expression. Understand? By the time you move this sign of variation sign, you put equals to and put a k constant. So this k, let us get this k first, because this k we are going to be using it when the variable is changing. For the first variable that we have, we said say square root of x. Y varies directly as the square root of x, and y is 3 when x. So at this instance, we can find k quickly. So when y is 3 is equals to k, then x is what? 16. So k is equals to 3 over root 16. 3 over root 16 is 4. So k is equals to 4. If k is 4, when this thing now becomes this set, say we should calculate y when s. So when y is unknown and x is given as, I'm writing this equation again. Root. This is the equation I'm writing again. I'm writing it again. So when y is unknown and k is already known as what? 3 over 4. Please. 3 over 4. That's k. 3 over 4 here. So 3 over 4. Wow. 3 over 4 times what's x in the new one? Root 64. Y is equals to 3 over 4 times root 64 is what? 8. That's because of 64 is 8. So 4 here 1, 4 here 2. So y is equals to 6. So this is the variable y. Y is 6 at this instant when x is what? 64. So we are going to call it a day in this particular video. I hope it has been informative for you. I'd like to thank you for viewing it. Kindly subscribe to our channel to get more exciting videos. Thank you for watching.